always have the option to do the log of both sides. We can change forms, but you can also do the log of both sides. With log equations, the big one is probably that one-to-one property, right? So what we're going to talk about today is what happens when the bases aren't the same. You know, with exponential functions, you can, like I said, do the log of both sides. With log equations, you can't, there really isn't that option. So you pretty much have to change forms. In other words, turn them into exponentials, which is a little bit what you're going to do here, although you won't have to because of this thing we call the one-to-one property. Okay, so what do we do first when we see this minus here? Combine that or condense it. And one of the things we're going to talk about on the test, there'll be on the test tomorrow, there's going to be some problems where all you have to do is condense or expand is what it'll say. So pretend this isn't even over here. Pretend in this problem just for a minute that this part isn't even here. So on the test, there'll be some problems where it'll say just condense this using the properties of logarithms. Okay? So all that means is you just turn this into x plus 6 divided by x. And we're going to review those properties again and so forth, right? But now, it is an equation, so we'll go ahead and put the rest of it, and you'd just be done. You would just stop right there, okay, if that's what the problem said, to condense it. But now you've got this. Now, the other thing you could do is you could subtract that log over there. You could have done that in the beginning. We could have subtracted that log 2 over there, but I don't think there's really a need to do that. You could just leave it like this. Okay, so now what can you do? Yeah, drop the logs, cancel out the logs, don't say divide by the log, right? But you can, and even cancel kind of leads you to believe you're dividing a little bit, right? But it's just saying that if you have log base 9 of something equal to log base 9 of something else, that those two things have to be the same. So it's x plus 6 over x equals 2. You go from there. Okay, now that only works because these two are the same base. We're going to look at a problem here in a little bit. What happens if that was a log base 9 on the left side and it was a log base 3, let's say, on the other side, right? Then this doesn't work, what we have here. So only if they're all the same base does this work. And a lot of the time they're going to be for what we're doing. Okay, now it's just some algebra. So now you're going to multiply the x over to that side. And then you're going to subtract an x. And you get that. Okay, so it's just done. Now you always should go back and plug these in. Remember, with logs, you cannot have a negative inside the log as an input to the log, or a 0, right? It's got to be positive. So if you put 6 in here, 6 plus 6 is 12, that's fine. Put a 6 there, it's 12, that's fine. Or a 6, that's fine. So no problem. No problem there. Okay? All right. Anything else? 19. On that same worksheet. Okay, so you have log base 8 of 2 plus log base 8 of 4x squared equals 1. So we can put those two together as a multiplication. So that's log base 8 of 8x squared equals 1, like that. Right, so we can take, put this together as a single log. So again, that's compressing them. And then you've got a couple of choices here of things you could do. But, well, really, the best one is now just change forms, right? When you have a single log, so in this case, we had a log on one side, log on the other side. That's that one-to-one property. But when you just have a log on one side or an exponential on one side, you want to get that by itself, and that's what we've done. So this is just 8 raised to the first equals 8x squared. So divide by 8 plus or minus 1. Now, we've got to plug that back into the original. It turns out it is okay. So this is where sometimes people say, oh, you can't put a negative into log. So you think, well, you can't use -1. That's not true. That's not what we're saying. You can't have a negative as the input to the log. This whole thing here in blue, this thing can't be negative, right? So you put a -1 into there. -1 squared is 1 times 4 is 4. That's fine. Log of 4 is fine. Okay? And so 1 or -1. Okay, and it makes sense because if you put a 1 or a -1, you're going to get 4. Well, what's that saying? That's saying log of 2 plus log of 4 equals 1. Sure enough, if we condense that, we can put that into a single log of 2 times 4, which is 8. And yes, that works. 8 to the 1 makes 8. So it makes sense that plus or minus 1 is our solution. Okay, what else? 24, same worksheet. Okay, ln of negative 3x minus 1 equals, or no, minus 7 ln 7 minus ln 7 equals 2. Okay, so again, we put that together as a single log, so it would be negative 3x minus 1 divided by 7 equals 2, like that, right? So again, whenever we have a log minus a log or a log plus a log, we can combine those as a division if it's minus or a multiplication if it's plus. And now, and if we had a log on the other side, if we had an ln on the other side, one-to-one property, here it's changed form. So we got a base e. So e raised to the second equals negative 3x minus 1 over 7. Now again, you're going to get to use your calculators on this, except for one part of the quiz, which we're going to review here in a minute, the evaluate part. But right here, we would just multiply. Now you could go to a decimal on this. I wouldn't right now. I would just leave it e squared until you get to the end. So let's multiply by 7. So we get that. Now let's add 1. So 7e squared plus 1 equals negative 3x. And then divide by negative 3. So 7e squared plus 1 divided by negative 3. And to be honest, I kind of like that answer. Why not? Just leave it. Okay? But if you want to go to your calculator and use that, and that E button, I think when you hit the E, it puts a little power. Depends on your calculator. So you can just do e to the first. So you go 7e, well, except you want e squared here, I guess you wouldn't put e first. If it was just e, if you were doing 7 times e, you could do that. 7e squared plus 1, whatever. No, good question. That's kind of like, well, I am. I mean, you mean to make it 8e squared? Yeah, no, because that's kind of like x squared. It's kind of like if you had 7x squared and you wanted to add 1 to it. It'd have to be 7x squared plus 1x squared. That would give you 8x squared. So if this was minus 1e squared, right, we add it over, 7e squared plus 1e squared would be 8. It's like terms. Okay? All right, so then I don't know, it had a decimal here, I think, negative 17.57 something. But again, I'm fine if you just leave that. Okay.
Other worksheet number 23.
Five e to the 2.9m minus 2 plus 6 equals 94. Okay, so with exponentials, a little bit like logs, if there's just one in the problem, you want to get it by itself. Okay, so we want to subtract 6. So that'd be 88 divided by 5. So 88 fifths, whatever that is. I mean, you can multiply it. I mean, you can get a decimal because it comes out pretty nice, I think. What is it? 17.6. Okay, so that's pretty nice, not a repeating or anything. So now we got e to the 2.9m minus 2 equals 17.6. So now let's just change form. Now you can do the ln of both sides too. You can do the log of both sides, but these kind of just simple ones, especially with a base e. This is going to be log base e, which is ln, of 17.6 equals 2.9m minus 2. Okay, that's the key step right there. I mean, obviously these are important too, but they're just kind of algebra moves. But here it's log, so remember it's e raised to that makes that. So e raised to that makes it. So now we can add 2, so just ln, again, I don't go to the calculator usually until the very end. I just think that's probably easier, and then you don't have a whole bunch of decimals you got to keep track of. So you add 2, so it's kind of like Kale was just asking the last one. It's just ln 17.6 plus 2, and then the whole thing divided by 2.9. I mean, I really, actually, like I said, I really don't care if you leave it like that. That's probably okay. You know, it is okay. for sure. But then if you want to get a decimal, they've got 1.6786. And I think, if the directions say, I think this worksheet didn't say the nearest 10,000, so, and that's 4 decimal places basically. So if it says something like that, even if it says round your answers, to me, if it's a decimal, that's what they want you to round it to. If you're going to leave it like this, I'm okay with that. Okay. Anything else? On the other one? Okay. ln2 minus ln 3x plus 2 equals 1. Okay, so again, it's a minus, so we're going to do a division. Like that, right? And then we're going to just change forms. So we're going to go from log to an exponential. So e to the first is going to equal this, right? Like that. Okay, so now we're going to multiply this over to the other side. Now this is kind of like that one yesterday where we had a 2,000 over here and we had a 5,000 up here, and we multiplied this, and I said I wouldn't distribute that 2,000 through, I would divide that 2,000 over. And I think I would do the same thing here. When you multiply the 3x plus 2 over here, just leave it like that, and you're trying to get the x by itself, and now you can divide by e. You know what I mean? I mean, you can multiply the e through there, that's fine. I mean, let's go both ways with it. I mean, if you don't, you would get something like this. You'd have 3x plus 2 equals 2 over e, right? Just leave it like that. At the very end, you can divide if you want to. Now we're going to subtract 2. So 3x would be 2 over e, take away 2. Now you don't want to put that 2 up on top, or you can't subtract the 2 from that 2. They don't have common denominators. It's just 2 over e, subtract 2, and then divide it all by 3. And so it's 2 over e, subtract 2, all divided by 3. Now I know for some of you, you don't like that because you might mess up, how you write that or something, and that is a danger. So maybe you'd be better off on your calculator doing 2 divided by e, right, and getting a decimal, and then subtracting 2 and then dividing by 3. Maybe that would be better. It's up to you, okay? So you could leave it like that, or you could then get your decimal. Now the other way to go is you could distribute that through. So you have 3ex plus 2e equals 2. So when you multiply that over, maybe you're more comfortable doing that. Okay, that's fine. And then 3ex, remember e's just a number, okay? And so we get 2 take away 2e, and then we divide by 3e. So we get 2 minus 2e divided by 3e, and that is the same as that, which they will both give you the same, I think, negative 0.4219 is the decimal. So I'd be fine with it, either one of these two answers. I mean, a lot of people don't like this because it's a fraction in a fraction, and they feel like you ought to, maybe take the top bottom times e, and that's when it would look like this. But I'm not that interested in that part.
So when you have like the e times the 3x plus 2, can you just not distribute it on 2 over e?
That's what I did here.
Oh, okay.
That's what I'm saying, yeah. Yeah, right there. Yeah, just don't distribute it, have 2 over e, and then just get the x by itself. Either way you go there is fine. Okay? Any other? All right, so, and that's a part of the test, solving these equations. It's a reasonably big part, but probably, maybe half. Might not even be half. All right, let's take a look at a couple different things that'll be on the quiz. This is the no calculator part. This is like the little 10-question quiz we took the other day. So you'll have there'll be one part of the test that's just that. So why don't you go ahead and try those real quick here. No calculator. All right, number 1. How much? 5. 2 to the 5th is 32. Okay, number 2. 1. 7 to the 1st, right? Anytime you have a log base 7, And then that same base inside there, not 7 to the first, that's going to be 1. Okay, 3. Negative 2. 1/25 is 1 over 5 squared, which is 5 to the negative 2. So log base 5 to the negative 2. It's negative 2. Number 4. 0. Log of 1, any log of any base of 1 is 0. But this happens to be base 10, right? No base, it's a 10. 10 to the 0 would make 1, so it's 0. Okay, number 5. 6. The base, again, that's a lot like number 2, right? Same base. They cancel each other out. You're left with the power, the 6. Okay, number 6. Negative 3. It's 1 over 1,000. 1 over 10 to the third is 10 to the negative 3. So that is negative 3. Number 7. It's a lot like 5, a lot like 2. Those kind of just cancel each other out. The answer is 3. And what about the last one? 3 fourths. Very good. 3 fourths. Now, again, maybe, see what your thought process is on that. But when I'm looking at that, first thing I look for is I think, okay, 16 to the what? Well, 16 to the 1/2, that's square root. That'd be 4. Oh, wait a minute, though. 4 doesn't make 8. Now, 4 times 2 makes 8, but you need a power. So then the next thing that came to my mind is, oh, what about that 8? Well, 8 is 2 cubed. Oh, okay, 2 cubed. How can I get a 2 from that 16? 16 to what power? Square root of 16 is 4, but how can I get a 2? Oh, the 4th root. The 4th root of 16 is 2. So I need the 4th root to get my 2, and then I need to cube it. And remember, the bottom number is your root, top number is a power. So this would be the 4th root of 16, which is 2, then cubed would make 8. So 16 to the 3/4 power would be what makes 8. Okay, so a little bit trickier there with the fraction. All right, let's try this one. Kind of a fun little thing. Okay, see what you, if I could just have a picture of everybody's face right now. Okay, just look at that. You can use your calculator. I would not recommend typing them all in. But if you think about how you would do it on the calculator, it kind of gives you a hint of what to do. Okay, I've said enough. Think about how you would type it into your calculator. Okay, so, all right, so let's talk about a couple of more challenging, possibly, solution equations. Possibly more challenging, and there could be some of this on the quiz, a little bit. There'd be more ones like the worksheets that you did yesterday. That'll be the major emphasis on the equation. But we want to, it wouldn't be right to be in an honors class and not try a few challenges. Right? You would feel cheated. You would feel cheated. Okay, so we should do a few more challenging ones. Okay, so now the bases aren't the same. Obviously, if this was 2 to the 3x minus 1 equals 2 to the x plus 3, right, then that's the one-to-one property, right? Then it's just as simple as dropping the 2's and just saying, okay, right, we got that, and then just solving from there. So that part would be easy, okay? But if the bases aren't the same, okay, do that. Do that. Remember, we got 2 different methods that we've done when you have an exponential. Log of both sides or change forms, right? You got 2 choices. Okay? And I think exponentials are easier to, how many people took the log of both sides? What else did you do? Change what?
If I change the 4 to the 2 to the 2x plus 6 power.
Okay? Like that. The left side here. Let's ignore the right side. There's actually 3 ways we could do this particular one. Okay? So I said there were 2 ways. We changed forms, or we did the log of both sides. Well, the one I left off was the 1-to-1 property, right? And that's what you can do. Since you can change the 4 into 2 squared, right? You could get both of them with a base of 2, right? How many people did this? Okay, and you spend some time in Algebra 2 doing this kind of thing, so it doesn't surprise me you'd think that. So 4 is 2 squared. Power on a power, what do you do with it? Multiply, right? So that's going to be 2 to the 2x plus 6. So now we got them both with a base 2. So now we got 3x minus 1 equals 2x plus 6. So you subtract 2x from both sides, add 1, you get x equals 7. Okay? Now here's what it looks like to do the log of both sides. You do the log, and I always like to just do ln. You can do log base 2, but ln. Because you got 2 different bases, so which one do you choose? I just do ln. Now, what's the nice thing about doing an ln when you have a power like this? Bring it down front, right? That's the whole point of doing the ln of both sides. Bring the 3x minus 1 down, bring the x plus 3 down. Now it gets a little bit messy here. This is where this one runs into a little bit of difficulty. Right, the trick to this one, because otherwise you're going to have to get a decimal maybe here, which you could. You could type ln4 into your calculator, get a decimal, and distribute. You could type in ln2 in your calculator, get a decimal, and distribute. So it gets a little messy at this point, unless you do this. Understand that ln4, and this is something we do in calculus all the time in these multiple choice questions they have for the AP test. We have to do this. ln4 is the same as ln of 2 squared, and what can you do with that 2 on top? Bring it down. So ln4 is the same as 2 ln2. That's a lot like doing what you did right here. It's a lot of the same thing. So ln4 is the same as 2 ln2. Well, now look what I have on both sides. I can just divide both sides by an ln2. And that ln2 is now gone, and then that makes things a lot nicer. But it's kind of hard to see that. A lot of people wouldn't see that. So now you distribute the 2, and you get the same thing. Okay, now let me show you the one that most of you didn't think of, and this is the change forms thing. Here's why I like doing the log of both sides, or I like getting the like bases, the 1-to-1 property like you guys did. Because when you have an exponential on both sides, the changing form's kind of weird. But what I did is I wanted to write it as a log. Now, would you do a log base 2 or log base 4? It doesn't matter. I chose log base 2. It happened to be the one on the left side. So I was like 2 raised to this makes that. So 2 raised to the 3x minus 1 has got to equal this, right? See how I did that? So I just made this into a log. So I did log base 2 of that equals that right there. Now, what can I do with this x plus 3? Bring it down front, right? That's the whole point. So I can bring that down front now, like that. Now, what is that equal to right there?
2.
That's 2, right? We just got to doing those, right? Log of 4 base 2, that's 2 raised to the what? 2 raised to the 2. So that is 2. Okay, so now I can just replace that with a 2. Then I can distribute 2x plus 6 equals 3x minus 1 and get x equals 7. So 3 different ways there really to come up with it. I like what you guys did. Really, that's the first way I did it when I worked. It was change that 4 to a 2 squared. I think that's a really good way to do it. So depending on the problem. Now, what if this would have been a 5? That doesn't work, right? That doesn't work. Then doing this might have been a good way to go, right? Now the problem is you've got a log 5 here and you wouldn't have had anything nice. Well, you'd have to type in your calculator, maybe get a decimal. It's not going to come out as nice. So if you have log 5 right here, you can just do log 5 divided by log 2, right? Do your change of base, get a decimal, you can distribute, you could still go from there, okay? Or maybe this would have been the way to go. But again, even then, you're going to have that same problem. You're going to have a decimal and some weird stuff going on. Okay, let's try this one then. We're going to work this one together. Okay, so this is one you haven't really seen much of, but it's a lot like the one we just did. They got different bases. You got a 2 base and a 4 base. So unfortunately, and there's not a real quick, easy way to change this log base 4 into a log base 2. Okay, not as easy as there is with a exponential. I mean, there is a way we could talk about it, but I'm gonna show you this. Okay, I'm not sure a lot of you would think of it, and I'm not sure it'll make as much sense to you. Some of you, it might, and so if you can think about it, it would basically be like this. It'd be saying, well, wait, is there another way I could write this? So, so set that equal to, I don't know, something, call it A, and then you can go 4 to the A equals that, and then change that to a 2, then change it back to a log. So I'll let you maybe think about that. But otherwise, how would we do this? Well, it might be something like this. We look at, okay, so what we might do is what I was just talking about back here, where I said it's kind of weird when you got 2 exponentials to change it into a log, but you can still do it. Well, it's kind of the same thing here. It's kind of weird when you have 2 logs to change it into an exponential, but you can do it. You can go 2 raised to this makes that, right? You got a log, you can change it into an exponential, even if it's a log on the other side. So write that down. So 2 raised to all of this equals the x plus 1. That's just changing forms, right? So if you're stuck and don't know what to do, you can always take a log and write it as an exponential or vice versa. Okay, now, what do we do with something like this? Well, okay, here's where we want to change this base. See how you have a 2 base here, but you have a 4 base here, right? Now, remember, we just got done doing something on, well, we didn't do exactly this, but what if I gave you that problem right there? You know, on the no calculator part? Now, it's mostly sticking with log problems, not exponentials. But what's the answer to that? 3. When you have a 2 base raised to a log with a 2 base, they undo each other. They cancel each other out. Okay? Just like if you had log base 2 of 2 to the 3rd. It's the same idea. It's the same idea. Okay? These are both 3 for their answer. So what I'd like to do is get this to have a 4 for its base. Well, how could you rewrite 2 to have a 4 for its base? 4 to the 1/2. So I'm going to change that 2 to a 4 to the 1/2. Now looking at it, it might have been better for me to do it the other way. It might have been better to take 4 raised to this equals that, because then I could change that 4 into a 2 squared, then I wouldn't have this fraction. But it's okay. It's going to work out the same way. Okay? So now, power on a power, what do? Power on a power, you multiply. So this would be 4 to the 1/2 log base 4 of 2x plus 3. Okay, now, when you have, now that 1/2's kind of in the way. When you have a 1/2 in front of a log, what can you do with it? Put it up in the power. Remember the reverse of what we've been doing? If you have a power inside of a log, you can bring it down front. If you have a number out in front, you can put it up as a power. So we can put that 1/2 up there as a power. That'd be square root, right? So that's going to give me, go to the next page here. That's going to give me 4 raised to the log base 4 square root of 2x plus 3. But again, I was trying to do the same thing as we were doing last problem. When you guys changed the 4 to a 2 squared, you were trying to get equal bases. You were trying to get 2 and a 2 as equal bases, because that's your 1-to-1 property. That's also when things kind of cancel out nicely. So I was trying to get a 4 base with the log base 4, so they matched. Well, now what is this left side equal to? Just square root of 2x plus 3, right? Because now I got a 4 base raised to a log base 4. And I would always give that to you as like a 2 and a 4, a 3 and a 9, something that would work nicely. Okay? All right, now what do we do algebraically to work this? Square both sides. Square both sides. Now remember, when you square x plus 1, it's a FOIL. When you square x plus 1, it's a FOIL. So it's x squared plus 2x plus 1. Okay? Now we just need to get everything on one side. Right? So we subtract 2x, which is nice. Those disappear. And we subtract the 3, we get -2. Now, if the 2x didn't subtract, you might have a factor. You might have one you can FOIL out, factored or something, right? So you got x squared minus 2, so then we would add 2 to both sides and then square root it, right? So add 2, you get x squared equals 2, then square root it. Remember, that's plus or minus square root of 2. Now, do you stop there? When it's a log problem, originally, when the beginning problem was a log problem, you've got to double check and make sure they work. So if we go back to the beginning, plus or minus 2. Plus or minus root 2. Root 2 is about 1.4, right? About 1.4. Negative 1.4 plus 1, that's no good. That's no good, right? Positive 1.4 will be okay. Positive 1, so negative square root we gotta get rid of. So the actual answer is just plain old square root of 2. Okay? So, a little more challenging when you got a log equal a log and they're not the same base. The key is get them the same base, just like you guys did here. You didn't have the same base, so no problem. You guys figured out, get them the same base, and then that makes things work nicer. Okay, it's just a little trickier to get them the same base. You have to do it as an exponential. Okay, so you guys try this one. Let's see how far we can get on this one. Very similar. So just follow kind of the same thing we just did. Now, if I were turning this into an exponential, I would use the 27 as my base. I think that makes it a little easier. Got a couple steps up there if you want to look. If you don't. What has to happen? Any questions on any of those steps? They're all pretty much the same as what we did before. Power and a power you multiply. And what do we do with that little 3 in front of that log? We have to put it up as a power, right? You got everything sitting in front of the log. So we need to put it up. We have to put it up there as a power, which means we have to cube x plus 1. How do you cube x plus 1? Oh, you guys had, yeah, you did have a rule for that, didn't you? It was, yeah, so it was x cubed. I mean, you can do x plus 1 times x plus 1 times x plus 1. No, that's not it. No, that's not it. That's not right. That's if you were factoring x cubed plus 1 like that. Yeah, it's just x plus 1 times x plus 1 times x plus 1. We'll finish it when you get back.
That's what I have.
I'll be here after lunch.
Oh, okay.
Yeah, I know, I'm sorry.
All right, so what happens, and again, the hard part of this from here on out is just the algebra. I mean, so that can happen where, you get stuck in the algebra part of it. And I don't want to make it an algebra test, but there could be some on there where you have to do a little more algebra than others. And so right here, you get this 3 base and the log base 3 cancel each other out. You get this. So you just have to cube that. So when you square, so it's just x plus 1 times x plus 1 times x plus 1. Okay, well, x plus 1 times x plus 1 is this, x squared plus 2x plus 1. And then you just distribute, take everything times everything, and it ends up being x cubed. You get 3x squared. You get 3x, and then plus 1. Okay, now, what makes that nice, then, is that those subtract away. So it was kind of set up to work out nice, right? So those parts subtract away, and you just end up with x cubed plus 1 equals 0. Okay, but, and then subtract 1 from both sides, x cubed equals -1, cube root of -1 is -1. However, this is where you got to check it too, okay? So you get x equals -1, right? Cube roots, you can do a negative, right? And fifth roots, odd numbered roots. So -1, but if you go back to the original, if you put a -1 in there, you get log of 0. You put -1 in here, you get 3 minus 3, which is 0. Log of 0 is undefined. They can't be equal. Two things that are undefined can't be equal. So actually -1 turns out doesn't work. That's a lot of work for no answer. But, that's just it. No solution. So it turns out there's no solution. Okay? But that's the idea. Now, it dawned on me over lunch. We talked about all the different ways, on this problem, we talked about 3 different ways to start it. We talked about doing getting it another base, changing it to log form. Here we said get the bases both to be 2. Here we said take the log both sides. They all work. That's because we're using these different properties to help us. Well, same thing with this one. One thing I didn't think about doing here, which you could do, would be to do the change of base formula. Just like we said, if you had log 11 base 10, you can change that into log 11 divided by log 10, right? Change it to any base you want. Well, you can do the same thing here. You can change this to any base you want. So you say, well, let's say maybe I want these to all be base 2, right? And so I can change this into log base 2 of x plus 1 divided by log base 2 of 2. Now, of course, we know that what's that down here? That's 1. But remember, we said we can take this divided by this of any base we want. But then I could do this log base 2. I could say, well, this would be log base 2, 2x plus 3 over log base 2 of what? What would go right here? 4. See what I did? I'm doing log of this divided by log of this. That's a change of base formula. Now, usually we do it with log or ln because we want to use our calculator. So we change them to that base. But we could change them to some other base. And see, that way you get your bases to agree. Now, this down here is just 1. And what's this down here? That's just 2, right? 2 to the second makes 4. Now, all of a sudden, we've got this. Now, you can't set these equal because you got this 2 here, but multiply this 2 over here. Now you get 2 log base 2 of x plus 1, right, equals log base 2 of 2x plus 3. So just, some people would think, oh, this is confusing all the different ways, but if you're really understanding how those properties work, it makes sense that there'd be multiple ways. If you understand properties, you can pick one that's going to work for you. Okay, now we can't set those equal to each other because we've got this 2 sitting here. What can we do with that 2? No. No. Yeah, power. We can bring that in as a power. Remember, any number in front of a log can come in as a power. So now we got log base 2, x plus 1 squared, right, equals log base 2, 2x plus 3. So that was a way, using the change of base formula, was a way we could get it all to be the same base. Now, what's x plus 1 squared? That's x squared plus 2x plus 1 equals 2x plus 3. Okay, now subtract the 2x, subtract the 3, we get x squared minus 2 equals 0. Remember, this is the one that was plus or minus square root of 2, right? We did it a different way. We ended up getting this, we squared both sides, we still got to here, we got the same thing. So that's just a different route using those rules that we have that could make that work. Okay? All right. So, just real quickly here, these are all things you've had in your notes before. So I just wanted to run through, but again, we've talked about our log properties. You know, log, when they're added, is multiplied. When they're subtracted, that's a division. And then the one we've been using a lot here is when you bring that power down in front, or if the power's down in front, you can put it up there. Okay, those are the important properties, and then of course the change of base, right? We can change the log like this into any other base we want. Usually we use log or ln because we got our calculator, right? Okay, so for the test, basically 4 things I would write down here. Expand or condense, right? Expand or condense. So, if you want to jot this down, that's fine. I'm going to give you a worksheet that's going to have some of all this on. Expand or condense. So, the directions for this one would be condense, right? And so, we got this 2 out here. That's a problem. So, what are we going to do with that? Make it log of 36 minus log of 4. What is going on? Plus log 2x. Now what? So this would be 36 over 4, which is log of 9 plus log of 2x. What can you do with that? 18x, right? Log 18x. Because you multiply it, right? That's condense. Okay? What about this one? The directions here would be expand. So it would be a plus, minus, and the order of operation is kind of important, but you could put parentheses around this, but it's a plus, and so actually they're not needed, but you could think, okay, those 2 on top would kind of go together and then divided by, but we shouldn't leave it like this. What do we want to do here? Bring the 2 down, bring the 3 down. Okay, so our final answer, we'd want it to be 2 log x plus 3 log y minus log z. Okay, so that's expand, condense, so those properties we just had up there. Okay, convert. There's not much to say here. We've been doing it a number of times with a lot of different type problems. We'd just be able to convert from exponential to log form. And I might give you some problems where that's simply all I ask you to do. Right? Give you an exponential, say convert to log form. Give you log, say convert to exponential form. So I'm not asking you to solve it or anything like that. So if I give you log base 2 of 4 equals x, and I say convert that to exponential form, I don't want you to tell me x equals 2. That's not what I'm saying, right? Convert to exponential form means you write 2 to the x equals 4, and then that's your answer right there. Okay? So in the convert problems, it's just doing that. Now, it might say convert and then solve or something, so just follow what the directions say. Okay, evaluate, that's the no calculator part, okay, that we already talked about. Be a little bit of that. And then solving the equation. Okay, all right, so these are optional. Oh yeah, and I would give you these formulas if there's any interest in those kind of problems where you have to do something. So, you could plug in and then use your calculator to solve and that kind of thing. Okay, those are optional out of the book. This is the homework though here, is this worksheet. Okay. So optional is just simply if you want to look, what I would do is I would look at each of those groups of sections and say, okay, do I know what's going on there? Could I work these? Maybe I might want to do one or two just to see, whatever. Okay, but this worksheet's a decent review of different things, but it's not like it's got everything on the worksheet. So maybe looking at the ones in the book's not a bad idea. The answers to the worksheet are up here. Okay.
Yeah.
What are you doing?
Why did you?
Mark, what's the one in this?
So,
What is, like when you break that down, what does the one represent?
Okay.
Because that's the answer on like the worksheet, but that's not how I originally had it.
Oh, because 15 can break down 3 times 5. So, right? So in other words, you broke it apart as 15. Okay, so you got log base 3. 15q. So that's this.
Yeah.
Right?
That's what I had originally.
Right. And so you had 15 times q, you broke it into 15q. But 15 is 5 times 3. And the reason that's important is because it's 3.
Okay.
So we go log 3 plus log 5. Right? 3 times 5 is 15 plus
So
log
that's
q.
simplifies.
And then
Yeah,
3
that's
to the
the one.
first, and that's the one.
Okay.
Yep. Yeah, that's a good one there early on. What number was that?
4 on 6.4.
Yeah, when you have, like log 15, okay, and they talk about expanding it. It's easy if it's like 15, well, it says 15q, so it's easy to say, well, you can split apart the 15 and the q. But you can also split apart 15 into 3 times 5, and of course you would want to do the 3 because of that 3 there. So you can take this log 15 and break it into log 3 plus log 5. And what's log 3? Log 3 is 1. So that's 1 plus log 5. So you should think about doing that too.
So we left it as log 3 of 15 when we get 0.6.
If it was a problem that said expand, yeah. Because that would be equivalent of if I gave you one that said log xy, it said expand and you left it log xy. You know what I mean? So yeah, and you're right. We haven't done a lot of those, but on an expand one, we want to do that. The key to that, Jack, is what base is this? How can you expand it using that base?